Hey, I wasn't really gonna do any more video stuff because I don't really enjoy it. Um, and then I guess I watched too much chemistry YouTube, and I got kind of interested in a project that I'm already doing, which is that I want to make um, or extract, not really make, lithium. It's an element, you don't really make it, um, out of disposable vapes. Um, there's a lot of these around. There's literally millions and millions of them being disposed of every week in the UK. There's one being disposed of every 2 seconds, although that's actually a figure from 2021, so it could be worse than that. And that's just in the UK alone. So the fact they use lithium batteries is kind of wild if you think about the number of articles that you can look up, and I'll post some of them here, which are all like, we're running out of lithium, there's not going to be enough lithium. At least for the last 7 or 8 years, there's been one minimum once a month. There's like, Elon Musk says there's not going to be enough lithium by 2025, or like world's lithium will be completely exhausted by EV batteries by 2027, or whatever. EV batteries are not really, or only recently became a majority user of lithium in the world. Consumer electronics by far have been using the lion's share of lithium for a long time. So things like laptops, phones, um, anything rechargeable, pretty much. Um, and at the moment, these are using an awful lot of it, uh, which is pretty interesting, especially in a regulatory sense, because if you're making large lithium batteries, you're about to be regulated into the ground in the US, the EU. In the US, it's particularly car batteries being regulated. They have to be recyclable, they have to be recycled, and they have to be locally sourced in terms of lithium, or else you can't benefit from various tax incentives in terms of purchasing reductions on the end car price. So the consumer, if you're buying a Ford F-150 Lightning, you will know how much of the battery was locally sourced, because it will be reflected on how much you actually pay for it, in terms of the legislation, which is quite interesting to me, at least. And you're on my channel, so I'm figuring you probably are too. Um, and then in the EU, over a certain capacity, and I'll put like the number here. I just got back from Le Mans. I can't remember anything. Um, then those batteries have to be recyclable. They have to have an end of life plan. There has to be certain things in place. What happened there was that I just got back from Le Mans and was talking rubbish. So what actually is in the EU incoming legislature is that by 2025, overall 65% of batteries, as in the materials, not like 65% of the overall batteries that are made, have to be recyclable. And some elements that are in the batteries, like cobalt and nickel, which are like particularly problematic to mine. Cobalt is associated with atrocious human rights violations, particularly in the Democratic Republic of Congo, which is a very, very mineral rich state, uh, which is horrifically war torn. It's got huge amounts of corruption, and it's been exploited from horrible, horrible colonial times to the present by Western states. And mining there is pretty much done almost universally illegally. There's a lot of child labour, there's a lot of abuse, and it's basically where most of the world's cobalt comes from. Where most of the world's nickel comes from is places like Norilsk, which is one of the worst places on Earth. Basically, it's a city in the Arctic Circle in Russia. It's probably not a lot of nickel coming from there now because of, well, you know what's happening. Um, but it's horrifically poisoned. Nickel mining is really, really nasty. So those elements, it's really important that we recover them, that we don't lose them into landfill, that we're not being wasteful with the way that we're treating them. And so those elements have to be recovered up to 95%. 65% battery material recovery by 2025 is really ambitious, but uh, for obvious reasons, I think it's a really good idea. And it's actually a really good piece of EU legislation. So, yeah, sorry about post-Le Mans me talking abject bollocks there. These are really small. There's nothing that really applies to these. And the consequences of them ending up in landfill is really big. So I figure a genuinely useful project, as someone who's interested in batteries, is to look at, is it possible with a process that is doable domestically, even, to actually get any kind of meaningful or even trace. I'd be happy, please excuse my road, I would be happy with a trace amount of any kind of lithium carbonate at the end of, probably going through like 50 of these. But that's because I am not a chemist. My last chemistry qualification was a combined science GCSE more than 20 years ago. So, yeah, if I could get anything out of these, then I'm going to consider that a win. Especially because I don't have expensive equipment. I won't really be able to do any fancy processes. And so if I can do that, I figure that proves they are recyclable and that there could be a case for lithium mining basically from these devices, which would be a massive advance on the current situation, which is that a lot of them are either sitting around in people's houses, which is actually kind of scary to think about the number of these batteries that are like sitting dormant in drawers and stuff, possibly getting hot, all sitting next to each other, all leaking vape juice. Or they're going into landfill, and we know, for instance, in the UK alone, there's been 12 recorded fires on garbage trucks last year, where basically a lithium-ion battery got crushed. Doesn't necessarily mean it's one of these. Could be a phone, could be anything, and it doesn't matter if it's a Porsche Taycan or whatever these called, Lost Mary. Oh, Bloody Mary. Multiple brands. Whatever it is, lithium. The lithium in the battery will burn at the same temperature, which is frighteningly high. And because there's not very much in one of these, it won't burn for very long, but the intensity of a fire from it, once it's pierced, especially because most of these are not fully discharged when they go into landfill, once they're going, they can obviously then set fire to any other garbage that's next to them. They can actually set fire to steel, which is exciting. And yeah, then you've got a really big problem. So, I just got back from Le Mans. Let's not pretend this video is going to be in any way coherent. This, here's one I pulled apart earlier, and I kind of wanted to talk about like what's in these things, which is quite a lot of nothing. So I pulled the sponge with the vape liquid out of this one because it's gross and it really was like stinking out my room. But you can see there's like still kind of bubbles of it. This isn't, I haven't taken the top off that. That's just literally how it's packaged. There's nothing else defending it in here. It's kind of got like a seat, like a plastic frame at the bottom, but that's it. Yeah, other than that, it's pretty basic. There's the battery is crudely stuck on with like just a sticky pad. Looks very like a kind of Blue Peter project. The battery loosely, I guess, is insulated with a bit of plastic wrap that just covers over the solder at the ends, and then largely uninsulated, although it sits beneath the battery, so it's relatively well defended from the vape liquid, is the heating element, which is a metal heating element. Some fancier vapes have like ceramic heating elements and stuff, but these are obviously cheap. And then you can even pull it apart with false nails. This is the wig, which just goes up through the vape sponge and gets hot, and it's, you know, it's a wire into some fabric, heats up enough to be able to atomize the vape juice. And that's it. It's not a very clever device. It's a 550 mega hour battery, which actually is bigger than I think they're using now in these type of ones. Although the other kind, the kind of like long elf bar ones, I know they all have like 1,000 brand names, but like basically the stubby ones and the long ones. And the long ones have significantly bigger batteries, but recently these ones seem to have gone down to like a 360 mega amp hour battery, which isn't because they're like, ooh, we'll save lithium. It's because they can charge people the same amount for the same thing. These batteries, I haven't tested this one, but they're never fully discharged as far as I can tell. Whether that's because I'm picking up vapes that people have dropped on the pavement and therefore they're not done with. There's usually also quite a lot of vape liquid around, or whether it's just because the mechanism doesn't discharge the battery fully, I don't know. So the first job is going to be getting my collection. I've got like quite a lot of these. Discharging it fully, because it's going to be hopelessly dangerous otherwise. Pulling everything apart. I do want to keep the electronics, so the wires and stuff, and even the solder, and see if we can extract anything from that, because there are some relatively precious metals that get used in that. So that would be interesting. That might be a bit beyond me, but we'll see. And then break into the battery casing. These are lithium polymer batteries, which the way that batteries are described is very confusing, because sometimes it's referring to the chemistry, sometimes it's referring to the physics, and there's obviously a sort of mixture of the two. The chemistry, so lithium ion sounds like a chemistry, but it's actually talking about the physics of a lithium ion moving between the charge points, or between the electrodes. And then lithium polymer is a type of lithium ion, so it's still a lithium ion that's moving, it's just got a different electrode, electrolyte, which is what the ion moves through. And there's all kinds of different types of lithium ion, like solid state and stuff like that, which solid state sometimes gets referred to as though it's going to be different from lithium, but it's still a lithium chemistry, it's just with a solid electrolyte. And so, yeah, a lithium polymer battery just means that the like electrolyte is a polymer. And then within that, there's different chemistries for lithium polymer batteries. Now, I don't know, and I can't find my working, so like this is a really good lesson to anyone who is doing anything, to always write down notes and not assume that you will remember this a week later. But before I went to Le Mans, I was really excited because I thought I'd found a relatively easy to do at home, probably might be successful and not too dangerous way to extract lithium carbonate, which is the goal. That's the stuff that you make batteries out of, or the raw material for batteries, out of LFP batteries, lithium iron, so as opposed to ion, batteries. Oh, sorry, lithium iron phosphate batteries. So in theory, I could take the polymer out of those, strip it down. There's kind of like a sort of like a Fruit Loop, like curled up thing in here, and you can pull it apart in strips between the cathode and the anode. They're pretty crude, and then one layer will be the lithium polymer, which for some reason, and it does feel like or maybe it should be true because it would be safer, but I'm not sure why I'm so convinced that these are LFP. If they are, and I'm obviously going to have to spend a few days retracing my internet steps and working out how I decided this, but if they are, then there's a way for me to do that using ammonia persulfate, according to a really interesting paper that like I'll put up some links and some stuff. So I'm not making this up by myself. This is something that like actual scientists who know things have looked into, and they think that putting the polymer in ammonium persulfate would cause basically a reaction, whereby what you're left with, or you can like precipitate lithium carbonate out of it, because the iron reacts with oxygen, which that's a common one, rust, and then what you end up with is that like basically the lithium self-selectively removes itself. Hello again from not post Le Mans Hazel. Whilst I'm lying in bed trying to edit this mess, I realised that once again I was just sort of saying words, and what I meant there was that the method actually, to be fair, was reasonably sound, in the sense that yes, it will involve opening the battery, spooling out the Fruit Loop, and then getting the polymer, but what happens is not precipitating anything out, because aside from anything else, I need some fancy material for that, and like, tubes and whatnot. What I'm hoping to do, assuming any of this is right, is leaching, which is a lot more straightforward and a lot more passive. So basically, what happens is that the iron in the LFP is turned into a ferric kind of different. It becomes iron 3, which sounds sort of I don't know, like elements are like this, all right? And that means that the lithium is kind of isolated, and that what you actually end up with is genuinely lithium carbonate, which, if it's that simple, is incredible. Um, I feel like it's probably not that simple, especially because we're coming up to, you know, peak summer in the UK and particularly in London, and it does it ambiently at 40 degrees, which is really not hot. Like, because the main problem with a lot of battery recycling techniques, aside from the fact that you need like severe acid, and this doesn't actually need particularly strong acid, it just needs a ratio of more ammonium persulfate than you have LFP, um, but it's not massively more, and so it is like realistic that I could put it together in a beaker at home, um, and yeah, if it works at 40 degrees, not, you know, 2000 or a couple of hundred degrees even, then this is kind of mind blowing, and it should be being done on an industrial scale. Um, but yeah, I don't know why I said precipitating when I meant leaching. I can only blame whatever was going on with the remains of my brain from Le Mans. Um, yeah. So I think it's a good sign for this, because traditionally YouTube chemistry videos don't work, and it would be kind of a shame if what happened to me is that everything just worked and I just found a paper that made it easy and then it worked, and then I was like, oh hey, we should recycle vape batteries, because it would make me seem like a fake and a fraud. So I think it's good that already I'm up against my own enemy, um, me, one of the classic narrative structures. Yeah, we'll find out what my logic here was in like a week's time, when hopefully I'm not covered in mud and can remember where I wrote something.